when my screen is visible.
Yes, it's visible now.
Okay. Yeah. So, yeah, thank you for the introduction. Some of you, if you have attended yesterday, I did a presentation on big data for cybersecurity. Today's focus will be mostly on the data science side. I want to talk about what are the uh, things that is kind of like important to consider data science as a career path. I have a poll, so I think when Citelo can start, like when I'm introducing, obviously my first couple of slides is introduction. So I want to ask like for folks like where they are in the career to begin with. Are we just trying to learn the space, like which is aspiring data scientists, or you want to transition to data science from different career fields? Are you already working as a data science, or others if none of this is applicable, right? So yeah, so let's participate on the poll, and while I just go through my couple slides. So today's talk, I want to focus on this mostly the four vertex, uh, the career path, data science. Obviously, I will like talk about what is data science, how it looks like. Then there are a few myths in the data science career. I have been in the industry for some time. I've been hearing like, hey, is this just a hype? I'm hearing like you need a PhD's degree. Couple of them. I just don't want to talk about everything now, but like those are some of the myths there. I want to clear, what is reality and what is kind of just the market talk. Then I'll briefly touch about interview tips for data science, right? So what to do, what not to do, then how the job market in data science looks like, right? So everyone says, hey, this is pretty hot market. Obviously it is. Just want to give a highlight that how it looks like today. And so if you guys know me, right, so from yesterday, I don't want to talk too much about it. I work in VMware now. Past experience working on Microsoft, Wells Fargo, the government is pay war, and I'm a US Army vet. So today everyone follows the QR code, so I just put my own QR code there for the LinkedIn profile. So you guys can give a try when I'm just talking. Just scan it. If it works, then connect with me or follow me right on the LinkedIn. I do share a lot of good contents in LinkedIn. Actually, mostly try to do on daily basis. Especially, I cover data science, machine learning, uh, even sometimes the emotional intelligence, diversity in workplace, like various things, kind of like non-technical as well, right? Which is important in career path. So then we talk about my career progress. I just don't want to stay too long in this slide. I did my undergrad back in Nepal. I moved to United States for my master's, and then I went to Army and I started doing a couple of degrees on business as well as in data science from University of California, San Diego. My the the highlight here would be it's not a number of degrees I collected, but the continuous learning path I have, right? So I believe that learning should be always continuous. There's no period for it, right? So in data, especially in data science career now, if you plan on transitioning, there's a lot of learnings like we have to try to do on daily basis. So this is an interesting slide. I love this slide myself because my career path is like from US Army to being a data scientist, right? So it's not, it's sometimes people say that's not fairly common or they hear it. Like you were in US Army holding a gun, now you hold a laptop doing the data science, right? So how was the career path transition? For me, when I came to States and then finished my master's, I was like, it was time of great recession, if you remember, to 2009. And then that point of time, like we were finding a tech job directly out of the college was kind of like struggling. Then military had some sort of pilot program. They tried it for a couple of years where they were, if you meet some of the criteria they have, they were kind of recruiting. I always had a passion to be in military, to be frank. Even back home, I went to military school for the last 2 years of my high school, and my, like some family members, close relatives who were in military. So I was inspired. And it was fun. I think the 4 years I spent in military, I learned a lot, especially from the non-tech side, leadership, team building, uh, you know, some attention to detail. All those soft skills we list in the resume. I mean, I know how that matters, and then how I become a different person. Like when I came out of the military. So the transition to data science path after I came out of military, I just joined the school uh, to complete my master's, another master's in the data science, and I was interested in the field, and I right after military, I worked as a data analyst. So, I mean, I thought maybe I will kind of like learn about more into the analytics field and then be a data scientist, right? And the transition path was long, but it was a fun ride, I would say. So let's talk about our presentation some of the common grounds I listed before I want to cover. So the first thing is data science career path itself, right? So where I want to cover is what is data science. So I picked the definition of science straight out of the Wikipedia. What it says is, okay, it's a systematic approach where you organize the knowledge with testable explanation and predictions of the world, right? So it makes sense now, like how it combines, how the science combines with the data now. And then I come out with my own definition saying data science is a field of study that actually helps us build the knowledge, because science is building the knowledge. Okay, so by extracting insights, right? So from the raw data, you got to extract, you got to process and get something out of it, identify the patterns. Then you test a hypothesis, like like, okay, I feel like, hey, does the house price depend on uh, square footage or area of the house? I mean, my hypothesis is yes, yeah, it's going to depend on, because bigger the house, the price will be higher. But I have to test those hypotheses, right? So that's when you're going to relate those predicting variables with your target variable. Target variable is your house price, right? And then making prediction, obviously the follow-up for that you make a prediction and then you validate your hypothesis, right? So if you look at it, extracting insights is data mining, right? So that's getting the raw insights. I mean raw data and getting insights out of it. Testing hypothesis is experimentation. This is what the industry calls it, right? And then making prediction is, we all know, machine learning. So now we know the definition of data science is about data mining, experimenting, and machine learning now, right? So this is how I kind of define and trying to correlate. Obviously, this is probably the popular slide you will see in most of the data science career related presentation, because what is the data science? It's a kind of sweet spot, they say. It's the intersection of programming, math, stats, and business expertise. And I do agree, because we need some sort of programming knowledge to build the proof of concept, or initially when you are getting some sample data and doing some analysis, you're trying to just build a project, right? You're not in the product side yet. You don't know what you can do, but initially you have to get some data, and exploratory data analysis, or EDA, is very popular in data science industry. So you have to do that. So for that, you need some programming. Then all the machine learning models, whatever you do, kind of based on the foundational knowledge of, like math and stats. So you have to know that, right? Because those are the ground uh, that you can establish to success. Because just learning the programming language and then using some Python packages, and functions is not going to cut it, right? You have to understand what's going behind it. Then the business expertise is important. A lot of people kind of miss out on this, because like you need to know at least 2 to 3 domain where you will be interested to work on in future. I say so 2 to 3, because until you try, you don't know exactly what is your interest, right? And sometimes your people's interests change. I mean, you can change your industry, right? But initially, I suggest folks to, like, hey, don't go after the company names, but pick some domains of interest, right? If you love shopping or like building a website for then recommendation engines, or like some of the associative learning might be a good way, right? If you like kind of like software industry or cloud industry, then there is multiple. Today, like data science is kind of like popular in every industry because it's not it's kind of domain agnostic, right? Because you can use for any field, right? Transportation, there is use cases for that. Security, there's a lot of use cases. That's where the industry I belong to. Uh, there is use cases for everything. Like healthcare is a big one, right? So those domain expertise means you need to understand a little bit about data, right? I can share my personal experience because when I first joined Wells Fargo from data analyst, my first data scientist job was for Wells Fargo. So and then so on that point, like I came from security domain as an analyst. I was working in the security, then I went to the finance, right? So it was a transition for me. I wanted to learn the fintech side, but I quickly realized that understanding the when I was working on building models, I realized that the domain knowledge is very valuable because I had to like do a lot of communication with the business stakeholders who is from the domain, like understand the economic model, the pricing model, to understand the all those things. It's very easy, right? Like I mean, it comes naturally if you love the domain and if you have some idea of the domain rather than just playing with the data, right? All right, so let's decide. This is the good one because on this one I break it down even in more depth. Like, okay, if I'm talking about programming, what should I do? So okay, so I got the poll result earlier, so it's good that we have more aspiring data scientists and people interested to make a career switch in the data scientist. The majority of people audience are like that, so I think it's probably going to be a lot helpful because my presentation is not geared towards like any data science project or technical in depth, but I briefly talking about career transition. So I think it's going to be helpful. Thanks for participating in the poll. So the programming, yeah, if you're just starting up, I will suggest Python because it's the learning curve is less steep. It's easier than other languages, and it's getting popular because of the support for the, it's because of the support. Hold on, I was setting the poll result. Okay, so then SQL. Obviously, SQL is important because a lot of people think that, hey, SQL is only important for data analysts, not for data scientists. And I kind of like debate that because initially, like I mentioned, when you are building the proof of concept, you need to get with a lot of data owners, try to communicate with them to get some samples data. And data is scattered everywhere. I mean, it's not like you're doing the project in a Kaggle where the data is given to you, right? So I mean, in the real industry, that's not going to happen. You're not going to have data to begin with. So then you got to connect with folks, and then a lot of and the SQL is going to be your bread and butter then, right? Like you have to have the pretty savvy on the SQL to write queries and get the data in one single place or in one file. Then you can do some analysis there. Without the data, obviously, you cannot begin your analysis at all. Lately, I started seeing the value behind the object-oriented kind of paradigm, right? So OOP is the object-oriented programming, so framework, because in data science, there is a lot of folks say, hey, I mean, you don't follow a lot of the data structures and algorithms and CSA fundamentals, but the shift in today's industry is that most of the actual, the most of the actual product is written in different language than Python. Obviously, Python is more geared towards the analytics or building the data science piece of it. But when you have to deploy that, like the your developers or software engineers, you're going to work with them. They're going to say, hey, it's hard to convert the notebook, Jupyter Note. You cannot just hand them, hey, Jupyter Notebook, this is implemented. Then you have to give them the class objects, things like that. And if you already orient your course, I mean the code like that is easier. The visualization is important. Out of the box Python libraries are there, or you can pick any tool. Tableau, Power BI is popular one I listed there. Big data, we talked about yesterday, right? Few tools. So Spark, Flink, Kafka is for streaming analysis. Airflow is very popular. It's a tool developed by Airbnb. I like it because I recently started using it, but it gives you the how you orchestrate your jobs. Like I said, you have to get data, you have to convert or process data to get to a different form, right? Um, and then if you are generating features, it's going to help during the feature engineering because you're going to schedule jobs and it runs in automatic fashion on daily basis or whatever schedule you pick, then it creates a feature for you, right? SageMaker is AWS analytics platform and the counterpart is Azure ML. So they are the ML framework from the cloud industry. And communication and storytelling, I cannot stress more on this point because this is very important because a lot of people, especially the data science job, is more like a you're going to have more visibility than any other roles, right? It's not a back-end software developer kind of role, but uh, it's going to give you more visibility, right? So all right, so those slide is there. So now let's talk about the career transition. How are you going to close the gap if you want to go on the other side to become a data scientist and you're already working as a so this slide mostly applies for people who is working in different career track and they want to make a career transition, right? On the left is like what you already have, on the right is what you want to gain, right? How you want to close the gap. So data analyst, I kind of belong to the first category there because you already have analysis skills, you already have some SQL skills and visualization skills, all the skills that I listed earlier on the previous slide. Then you want to level up on some ML skills, machine learning side, and coding part, right? If you already are software engineer, I think you have a coding skills, you have a CI/CD or DevOps mindset, you have engineering mindset. What you need is to fill the gap of product sense, stats and probability, or ML and soft skills. Usually, software engineers are more towards just writing the code, testing it, and pushing it in production, but they don't have much visibility or interaction with the business stakeholders. So they want to work a little bit on soft skills, and it is important. And the data engineer, obviously, I think have a little bit easier transition, I would say, because they are already playing with the data, they're building the infrastructure, they're building the ETL framework to have the data in the data lake or data warehouse. So they're actually the first folks of people who comes before data science happens, right? So that you need to have the pipeline ready. Then if they want to transition to data scientists themselves, then all they have to do is learn some data analytics and then stats and ML. That should suffice for them. The BI engineers or BI analysts, like what do you call it? So they are popular titles. They do have similar role like data analyst with little bit variation because they want to do more business side interaction. So they do more dashboard report building kind of work. For them, the soft skills is huge, but they have to bring some hard skills of tech like coding, DevOps, stat maths to become the data scientist, right? So this is actually covers for at least the four top categories we see in the analytics side who wants to kind of transition towards the data science. And I do get this question a lot. I do kind of like mentoring sessions, once in a while. And from my mentees, they ask me, hey, do I actually need a college degree to become a data scientist? Do I need a PhD to become a data scientist? Or do I need a boot camp is sufficient? Uh, Everything depends on what is your situation or what you want to do, right? So I created this decision tree to help those folks, like to make a decision. If you have some existing data analytics or programming knowledge, then obviously I suggest you don't really need a graduate degree because you can do some, like self-learning or so it depends on the where you fall in this decision tree. Let's see, let's do a walkthrough, right? And but for example, you already have some knowledge of analytics, right? So then do you want to switch to the data science career track like very soon? That means how much time you have. So you are like, hey, I want to switch in next couple of months, right? So then I would say the bootcamp helps because bootcamp is more expedited version of the training. So they give you like, hey, but obviously if you have more time, I don't suggest bootcamp because initially you don't want to cramp up everything and then try to overload yourself. So uh, usually the people I talk to have some time and then they want to do self-learning, or they already have some job and they want to do on the job training. They're like, okay, learn on the job, try to bring some ideas to your manager and say, hey, can we do a little bit of data science approach or data analytics approach on there, right? So it's easier if you kind of like do on the job training because it's a real time experience you want to gather, right? So this kind of covers like how or like if the degree will be valuable or not, right? So this is a decision flow that helps. Now let's switch a gear and let's talk a little bit about data science lifecycle. It's the journey of the data in a way. So you get the data to make it until the business value or deploy your model. So industry calls it CRIPS DM, which is cross industry standard. You hear this kind of like term a lot if you in the data science actually side. The good part about this is the iterative process. You see the circular loop going around. It's not going to complete. You just have to reiterate. That's when actually the real world projects are like that, because you set up your problem statement or you get your business understanding. You prepare the data, you build a model, you evaluate with your performance metrics, you deploy the model, and then when during the evaluation phase, you re kind of calibrate yourself. Like, hey, when you are evaluating the performance, you're gonna go back to your business understanding. You're gonna go back to your objective or problem statement, and then see if you are able to meet it, right? So. And it's a cyclic process. It makes sense. What you see there is the core of this process in the centralized data, right? I mean, which is very true because without data, I mean, obviously it's not going to help. It's sometimes the process heavy and documents heavy. The reason I wrote those 2 bullet points is because you're going to write these steps. Like if you are in data in that, if you are covering, if your role is to covering in the data preparation, for example, you're doing a lot of feature engineering, you're going to want to follow a process to document everything. So, but that's good, right? So in the real world, it's not like just doing a Kaggle project or building your own GitHub project that you just kind of like write your README the way you want. You want to write it in a good way to serve other folks, right? So who's picking up the same project. So this is actually a little bit complicated slide, but I just put it there. I created this slide myself actually. When software engineering merges with data science, this is important. Like if you're coming from software engineering background, this is more easier to understand. But I don't want to spend too much time. But what I'm trying to say on this slide is things can happen in parallel, right? In the when you're building or working on the data science project. The top half is the data science workflow, the same thing that I explained before, but it's kind of covers how you design an experiment. Setting up experiment is like your hypothesis, your what do you want to test, then what is your problem statement, then you do some feature engineering, which is obviously very important step in the machine learning, because that's when you are trying to learn what will be your predicting variables, right? So and then you build a model. So that's kind of like summarizes the data science workflow in a nutshell, right? So, but the software engineering side is like you want to start working with solution architect to begin with architecture design. Then you implement your pipeline or implement your code. Then you serve your model as an endpoint. So that's the software side of the data science, right? So, and in the industry, there's like, okay, how do these 2 things merge, right? So this kind of slide shows that, like there's a very close ties, right? Because software design is almost like you can work when you are doing the experimental design. When you're implementing the pipeline or code, that's also the feature engineering, like you build the features, how you want to implement it. I mentioned earlier, you want to have your jobs orchestrated through some tools like Airflow or something, right? So that is there. So we covered our section 1. So hopefully we're good in time here. Let me check. Okay, we are. And then So what are some of the myths in data science is our second talk, right? So, I mean, area to cover. So the top five things I'm hearing, I mean, is data science is just a big hype. And I mean, that's just a myth. I don't agree with that because yeah, it was a big hype or in the beginning when everyone is talking about it, like the market has still a buzzword to use like data science, machine learning, AI, and for everything, right? It has become a kind of marketing tool as well because companies wants to market, hey, we do data science. I mean, I don't know how much data science you do, but if they just do a small model or sprinkle of the model, they want to use it like they are doing it as a fire hose. That is the trend, obviously, but it's not a hype because data science is there and it has a value. Data science is all about ML models, and then that's not true because there's more to it. Like I mentioned earlier, you need to have some soft skills for presentation. I mean, you build a model, you are also presenting it. You need to have knowledge of math stat to build the ML model. You need to have knowledge of software engineering. Building the model is not only the thing, you have to push it to production. Without your model in production, it's no value, right? And one of the popular one I heard, like I mentioned earlier, to begin our presentation was PhD is required to be a data scientist. I mean, maybe the people have this thinking that there's a scientist in the title itself. I mean, usually PhDs are the folks who become the scientists. And I kind of don't agree with the point because I don't have PhD myself. I mean, I have my colleagues only with the undergrad degrees, so uh, I mean, your technical skills or your skill set matters more than just the education. Education is kind of values in your resume. Like I said, the decision flow before, if you have time, if you are just starting up education, the foundation, building the, I would say most of the PhDs are for the folks who is in the research side, right? So the idea is if you're applied, I mean, even applied scientists are without PhDs because they are the one with more software engineering knowledge plus data science. That's why they are called applied scientists because they build the model and apply in a real world to projects. The research scientists are the ones who companies here in prefer to give for PhDs a little bit preference because it's the research oriented, like those research scientists kind of work on a particular topic and then, like they find something novel and then write a paper, participate in the conferences. That's like research oriented kind of role, right? Mostly, and PhD values on those roles. But just for data scientist roles, I mean, it doesn't really matter. Learning all the DS tools will be enough to become a data scientist. I mean, I wish it is true because there's so many tools you can learn. Maybe you know 1 month, 2 months, 3 months you can learn everything, but you're not going to become data scientist just learning the tool, right? You need to kind of like learn from the industry or at least do some real world projects that kind of comes from your domain interest, right? And soft skill are, some people think that it's not important to be as much as tech skills, and I agree because obviously, like I mentioned, data scientists have more exposure to the business stakeholders or leadership that you try to present. Just think of it as your audience or your leadership does not know anything. They give you the raw data, and then they will ask you to produce value from it. So you definitely have to, like kind of like convert that into the non-technical language to explain it, right? They don't know the precision recall curve. I mean, they don't know the accuracy metrics. You have to break it down by what value, business value you're bringing it, right? So soft skills are very important in data science. So obviously, I already touched upon it. I'm presenting some data why it is not just hype. It has like all the data being generated on a daily basis, like I mentioned in yesterday's presentation also, right? Uh, we are living the world of big data. So what can help us is building data science and machine learning model on it to get the actual insights, right? So all of these numbers kind of suggest that the data science will only grow, not going to slow down pretty soon, right? And then this is obviously some bullet points that I explained earlier, like why it is not just about building the model, but it is more than that. Even machine learning model building is just one of the stages, right? So, and in when you are in data science industry, like you will realize that just building the model is very simple task. Actually, that is the probably the simplest task in the data science workflow. The challenging is to get the data, clean the data, and do the feature engineering, and that repeated iterative process I explained earlier on the Crips DM, the cyclic model. Yeah, that how much repetitions, iterations you have to do is based on how good of data you are processing and making features out of it. Because you can plug in model like just couple, I would say in scikit-learn or any packages you use, it's 2 lines of code. You just change a model like that. They already have the preloaded model, and it's just like it's more than that, right? So visualization is important. I cannot stress on that enough. Most of my slides is always going to talk about that. So the reason is I'm not trying to repeat it, but I want to make sure that people understand who's trying to break in the data science that soft skills are valuable as much as tech skills. So is PhD is a requirement? I already talked about it. The research scientist, and depends on companies. Like Microsoft, I used to work before. Microsoft kind of use data science and applied science as a top level job title. So most of the times, even the data like scientists, applied scientists, research scientists, they all fall into the same category. But doesn't mean that data scientists need the PhDs, but research scientists gets additional value of it. Companies like Amazon has very popular role for applied scientists, which I already talked about it before. So I just on this slide I break it down by top companies how they view the different roles. So mastering the DS tools, this one I don't know if you're familiar with something called Donner-Kruger effect. So Donner-Kruger, or like there's different ways of saying it, but I think the idea is uh, initially where you are learning something, you think that you know everything, right? So it's gonna be very high confidence with low knowledge in the field, right? So the people say little knowledge can be dangerous. That's when you're going to be on the trap, because uh, you feel like you know everything, but as you move on, then you take more projects, and then you're like, okay, then imposter syndrome is going to start hitting you. Like, hey, do I know everything? Like my colleague seems like he knows more than me, right? So and then the fault is because you didn't spend much time, right? So obviously to spend more time to gain more knowledge in the field has to be uh, linearly growth. It's not going to be like your confidence should not just raise like that. So if you follow that red line that I try to add there, then you'll be fine, right? You don't want to follow this the victim of this curve where you think that, hey, you know everything, and then you just fall in that shallow, right? So soft skill is important. So let me just, this is actually a real world example. It's from my LinkedIn, one of the posts I made. I downloaded it and just put in Excel and then draw two charts. The message I wanted to give here is on the left chart, I put everything in the bar chart. I cannot really tell from the left chart that what is going on, how is the trend going on, right? Because it doesn't talk about data anywhere. It's like, okay, I shared 10 tips, and then what is the post views? I just there's no ranking, right? So there's a ranking, but it's hard to tell. Tip 6 is popular, but it doesn't give additional message from the left visualization. Then if I plot in the time plot on the right side, and I can add the spikes or fall, kind of like highlight them with some messages, some text to understand. So if I present the right hand plot to the people, it becomes more understandable, right? So it's like, okay, you had tip 6 got popular because you talked about stats on there. Maybe people wants to hear about statistics more. Maybe the one of the lowest tip was, like not so popular one. So the only message I want to pass from this slide is visualization is also important, and you need to work on it a little bit, right? How you want to translate your findings. I mean, they both have the same data. I mean, it comes out of same data, but how you present it matters, right? The data science job market. Okay, let's talk about this a little bit. Uh, and then emerging jobs from LinkedIn. So artificial intelligence, there's a lot of growth. Like all the top jobs still kind of relates to the data science, robotics, and industrial engineering. It's coming up. Uh, and then this is just the data to share that the job is always growing. I took a snapshot from it's from the last year, so I don't know if Glassdoor already has it this year. So probably on 2021, data scientist was ranked number one, Java developer because they support uh, obviously a lot of industries and tools. So, but data scientist being in the second itself is very good news, right? For you to think about career transition. And there's always a growing demand, right? So if you just look for data scientists, and I mean, I just did the generally LinkedIn search, and then a lot of things gonna pop up. Uh, the post-COVID. So with the pandemic, it actually has increased the data science job in a way because people have gone remote, and then small to mid-sized companies have now realized that you know. They had cut down the roles during the pandemic, but it's picking up now, right? So, but they realize that they have to use the data to be in the competitive market, because pandemic told a lot of companies went, they unexpected situation, but they're like, okay, we have done better strategy in the market, to do a better strategy in the market, to expect anything for to sustain for a few years. I mean, we have used leverage our data to do some business value, right? So some of those things have come up. The It's like the world data science platform kind of reach, by 2024, it's expected to be like only on like 40 billion of data science platform. So in a way, platform is tools and like the technologies, and then obviously that means from data science perspective, it's like it's growing, right? So section 4, I'm gonna cover it quickly. Let me. That's our last section. Then we can do some Q&A. The interview tips. I suggest folks to start with this slide because just embrace yourself with a lot of no's coming your way, and there will be always a small s, somewhere hidden. You just have to identify. Applying jobs is a job itself. It's very tedious. When I made a transition from data analyst to data science, I mean, I had a lot of rejections myself. But what I learned from everything, every mistake is what matters, right? The one challenge is like most of the interviews don't give a feedbacks, but you will know that at least once you start doing more, you become more familiar, and then no one talks about your how many jobs they applied. In the LinkedIn, if you look, hey, I'm excited to share that I picked a job from Google, I picked a job from Microsoft. They don't show the data that how many jobs they were rejected. Some people do start doing it now, which is good because you have to share the failures, not only your success stories, right? That's my thing. Everyone has a big number behind it, so just think about that, like like to motivate yourself from rejections. This is my own number. First job in US, I mean, not the US, the data science job to get the like from transition was I applied a lot of jobs. The conversion rate is simply how many jobs I applied versus how many offers I got. So your conversion rate will get better as you move along the roles, right? So when I got my third data science job with VMware, the current one, I mean, it kind of like was not as hard as getting the first one. You see the conversion rate went up, right? The reason is your networking will be stronger and you don't have to apply as many jobs as you do for the first job for your other succeeding jobs. um, the application tracking, most of the times what this slide shows is like your number of jobs you applied for the first job is really high, but then for the second and third job it was very low. I didn't apply. It kind of sometimes comes from referrals or networking. So that's the same message I wanted to pass. Some of the do's, right? Like, what do you want to do? So read the job description properly. Don't apply to any job. So I mean, if you don't feel like you're going to be good fit, but I would say there's all the jobs are written in a way that it's not going to be 100% fit. As long as you are 70 to 75% fit to the role, you should apply it, because the way they write the job descriptions is their wish list. They want to have this, but it's not going to get, they're not going to get everything, right? So they know that. So always have a master copy of your resume, and sometimes you have to tweak a little bit depending on the job you apply. Pick a right keywords. So you want to pass those automated system in the beginning. Project portfolio is important. You build your portfolio in the Git or Kaggle, doesn't really matter, but it is very important. And then writing blogs in mediums and data science community is great. It helps, especially in the data for the data science. uh, and then always start with small, right? Like some people are like, hey, I want to break into the data science, and Amazon is my dream company. I mean, it's good to have those top companies on the list on your career goals, but I suggest to collect some experience, at least in the beginning, 1-2 years with small to mid-sized companies, and then try to ladder up, right? So because the competitions on the big companies is always high, and you're starting in the data science field, you have less experience, and you are competing with the people who have more experience. Obviously, your resume picking up is going to be a little bit challenging, right? And always soft skills again. I repeat that again. And what are some of the things that you don't want to do? You want to be selective to apply for the job, but don't be too choosy, right? Like, I mean, I just only want to apply for this particular company. I mean, you can always work for your dream company in the future, but obviously you don't want to be stuck on being not uh, optimistic like that. So be confident, then not be over or underconfident. Obviously it's a general statement. And then you want to apply, you don't want to apply every jobs you see. Like I said, some of them are marketed as data science, and then it may not be a data science job, right? You want to read the description well. And usually I suggest to follow as a courtesy, but usually follow up if you only did the uh, you know uh, if you only do the on-site, people say. But even after screening, phone screening, like, you can follow up with thank you emails, or it's very helpful actually. Following up, like, recruiters have a lot of other folks working with them, so don't, sometimes you end up working with bad recruiters, but in my experience most of them are good. Obviously it takes time for them to respond to you, because they are working with a lot of candidates, right? So, and more importantly, don't give up, right? So that was a part of the slide I had. So obviously you have to have your faith up. So this is it. We covered everything. I'm there in the LinkedIn again. I posted my uh, like the LinkedIn page over there. You can connect me, follow me there. Like I said, I post a lot of good contents for data science. And then, yeah, this is a word cloud I actually built myself based on all the posts I have done for a month. And you can see that, like, learning data is, I mean, obviously I talk about data everywhere. So data is the big one. And yeah, so if you have any questions, I'm here, to answer. So I open up the floor.